day again. So now we're on the last topic for our linear equation two variables, which is on perpendicular lines. So before this, we discussed about your parallel lines and how your slope is connected on these two lines. So same goes with our perpendicular lines. We are now looking at its slope, or we will look at its slope. So let's go first with our objectives before we go along this lecture. So our objectives for today, of course, we are or you are expected to define perpendicular lines. Of course, express relationship between the slopes of perpendicular lines. And lastly, you are to determine the equation of a line which is perpendicular to a given line. So let's start off what we think of perpendicular lines. So like this kind of crossroad, so these are like your perpendicular lines. So this like form of two straight lines intersecting together or intersecting with one another. But then there's something special about it. And that special is that as you can see here, you can see it forms a certain degree, which is 90 degrees. So you will form a right angle with crossing the two lines for perpendicular lines. So in any way, so for instance, you have two lines or two slanted lines, it's still, or if they are perpendicular lines, they still should have or they should form an angle of 90 degrees. So let's just define first the perpendicular lines. So for perpendicular lines, we are looking now at two distinct non-vertical lines, which is L sub 1 and L sub 2, which slopes are M sub 1 and M sub 2 respectively. So they are perpendicular if and only if their slopes are negative reciprocals. So please take note of the notation of your perpendicular lines. So it is read as L sub 1 is perpendicular to L sub 2 if and only if M sub 1 is equal to negative 1 over M sub 2. So we're looking at the negative reciprocal of the other slope. So commonly, the mistake of some students are they are looking actually just the positive reciprocal, not the negative one. So you have to take note of the negative sign here. So let's have some example first. So for example number 1, we are to determine whether these two lines are perpendicular with one another. So the first line is 5x plus y is equal to 10, and the other is negative x plus 5y minus 6 is equal to 0. In such case, since we are looking at its slope to determine whether they are perpendicular with one another or not, we can just have or we can just transform both of the equation into their slope intercept form. So let's start off with line 1. So for line 1, we have 5x plus y is equal to 10, where we can just simply transpose 5x to the right hand side. And the other one is your line 2, which is negative x plus 5y minus 6 is equal to 0. And same goes with line 1. We can transpose two terms, negative x and negative 6, to the right hand side. So let's start off with line 1 first. So for line 1, if we transpose 5x, we will have y is equal to 5x plus 10. And this goes that negative 5 is a slope of line 1. For line 2, if we transpose negative x and negative 6 to the other side, we'll have x plus 6, which is just equivalent to 5y. And then, dividing both sides by 5, we can have y is equal to 1/5 x plus 6 over 5. So meaning we have m sub 2 equal to 1/5. So 1/5 is just the negative reciprocal of your negative 5. Therefore, your lines here are perpendicular, or L sub 1 is perpendicular to L sub 2. Next example. So we have here, we are to write a slope-intercept form of a line that passes through the point -4 and -1 and is perpendicular to the line 4x minus y minus 12 is equal to 0. So first, let's consider this equation to be the equation of your line 1, while -4 and -1, or -4, -1 is a point in line 2. So we're to look first for the slope of your line 1 so that we can get its negative reciprocal, and that will be the slope of your line 2. So let's start off with your line 1. So to find its slope, we can just simply transform this into your slope-intercept form. So to transform this into your slope-intercept form, we can just transpose 4x minus 12 to the right-hand side. And what you'll get is negative y is equal to negative 4x plus 12. And we know already that slope-intercept form should have a form of y is equal to mx plus b. Therefore, we are to multiply this to negative 1 to follow that form. So we have y is equal to 4x minus 12, thus giving us m sub 1 to be equal to 4. And since L sub 1 and L sub 2 are perpendicular, we can have m sub 2 to be equal to negative 1/4. And following these points, so here, -4, -1, this is a point slope form. So y minus y sub 1 is equal to m multiplied to x minus x sub 1. So as we can see here, we just are to substitute those values here. So your y sub 1 will be substituted with -1. X sub 1 will be substituted by the value of -4. And our slope is -1/4. And then by simplifying this, we'll have y plus 1 is equal to -1/4 multiplied to x plus 4. However, we can just simply also distribute -1/4 to both of the terms, and what we will get is -1/4 x minus 1. And what we want to have is your slope-intercept form. Therefore, we can transpose positive 1 to the right-hand side and we'll get y is equal to -1/4 x minus 2. Therefore, or thus, the line that passing through the point -4, -1, and that is perpendicular to the line 4x minus y minus 12 is equal to 0 is y is equal to -1/4 x minus 2. So this is the line that we're looking for. Okay, for the next example, we are to look for another line, which is in standard form. This must contain the point, the point -4, -8, and is perpendicular to the x-axis. So remember, we're gonna look at your x-axis as your line 1, while -4, -8 is a point in your line 2. So your line 1 is a horizontal axis, and we're just going to consider this as y is equal to 0, right? So since x-axis is just at 0 of your y, so it is y is equal to 0, horizontal line. That's the equation of your x-axis always. Therefore, you have m sub 1 to be equal to 0. So for line 2, its slope must be undefined, or it should be a vertical line. So when we say vertical line, it's just equivalent to x equal to c, right? And we're just going to look at the x coordinate of what it passes through, on the point it passes through, and that is -4. So x should be equal to -4. Therefore, the line that passes through the point -4, -8 and is perpendicular to the x-axis is x is equal to -4. last example here. So we are to look now for the value of t. So this problem says that the line containing the points 5, 6, and -1 is perpendicular to the line passing through the points 8, 3, and 3t. So we're to look for t. So for its solution, so here, we are to look at 5, 6, and -1, 1 are as points in line 1, while 8, 3, and 3t are the points of line 2 or in line 2. So to find this value of t, we're not going to look for its equation, but rather just the slope of the lines. So let's start off with line 1, and then we can find what the value of your line, the slope of your line 2 is. So we have 5, 6, and -1, 1. So by using the formula for slope, change in y over change in x, we have 1 minus 6 all over -1 minus 5. And that is -5 over -6, and that will give us 5 over 6. And because they are perpendicular with one another, for 8, 3, and 3t, their slope must be its negative reciprocal. Therefore, it should be -6 over 5. So -6 over 5 should be equal to the change in y over the change of x here. So t minus 3 all over 3 minus 8. So simplifying, we have -6. I just put the negative sign on the numerator over 5 is equal to t minus 3 all over -5. By using cross multiplication, so we'll have 5 multiplied to t minus 3 is equal to 30, positive 30, because they are both negative. Since both 5 and 30 are divisible by 5, we can divide both sides by 5, and what we will get is t minus 3 is equal to 6. Transposing 3 to a -3 to the other side will have positive 3, so that should be positive 9. Therefore, the value of t should be 9. So that's it. So no need to find its equation, just find its slope. And that's the easier way how to find this or to solve this problem. So for any questions, please don't hesitate to ask and let me know if I can help you with something. That's all. Thank you.